In today's class, we are going to be looking at equilibrium of forces. And recall from our last class, we were talking about magnetic field. But today we will look at the equilibrium of forces. I will start by giving a clear definition of the term equilibrium. Equilibrium is a state whereby there is what? Stability. There is no net change, right? And the first definition of equilibrium we wrote, it said the body is said to be in equilibrium when it is at rest or moving with a constant speed. A body that is at rest in a single location, and such body is said to be what? Static. That is static equilibrium. If we have such a body, we will say that that body is in what? Equilibrium, meaning it is in a balanced position, undisturbed. Okay. Also, a body can be said to be in equilibrium. Now, this has to do with linear motion. For linear motion, the object is just at rest, or it is what? Moving with a constant velocity. Then we say such body is in equilibrium. While we deal with circular motion, we say that such object is not rotating at all. It has no rotation by its axis, or if that object is rotating, it must be rotating at what? A constant angular velocity. That's the idea of equilibrium. And for equilibrium, there is such a thing as a resultant force. When we deal with the story of equilibrium, the resultant force speaks about a single force that has the same effect as two or more forces. We have two or more forces maybe on an inclined plane. Let's say we have an object is suspended. Okay, if there is a balance, the balance in that object is due to what? A resultant force. So a resultant force most times is a force that is equal and it's in the same direction with the forces that it represents. For instance, if we draw a triangle, we can find a resultant force. Most times it is the hypotenuse of that triangle. It means this particular force. Let's draw a simple triangle for instance. If this is a two side and we have an extra side, how do I get to this point from this point A to point B? Or let's say point A to point C. There are two things here. It's either I go from A to B first, right? Do you understand? From A to B, then from B I will start taking another journey towards C. Or I can just go straight from A towards C. So it means that AC is the resultant of what? AB and BC. So that's the idea of a resultant force. While the equilibrant is a single force that balances two or more forces. We have two or more forces. There is a single force that can be applied to that system to give balance to two or more forces. And this principle is used when we hang objects. Have you thought of hanging a piece? You know, when you hang, for instance, a mirror, a frame of mirror, or a frame of a picture. Sometimes you hang that thing with a string that is not, with a rope that is not too strong. What happens? It will fall off shortly. So what do? You need to balance the force on that image. And that's the idea of the resultant force. It gives you a balance in equilibrium. So if we draw two forces this way, these forces, let's say they are inclined on a plane, the resultant force is a single force that has the same direction. So if you observe here, we have these two forces. One of the forces is here by this line is parallel to this, so we can represent this force by this dotted line. And the other force is here. So the resultant force is a single force that is drawn, such that it is what? Equal in both magnitude and direction as the other two forces. The equilibrium force is said to be equal to the resultant force. The only difference is that the equilibrium is in the opposite direction. So you have two forces. The equilibrium force will tend to balance the other two forces such that there is a stable equilibrium that is formed. Do you understand the idea of equilibrium of forces? So we have forces positioned. They are always arranged in such a way that they will balance each other, and that's the equilibrium, the idea of equilibrium. Let's take some examples on the resultant force. This first question says that two forces, each of which are what? 20 Newton, are inclined at an angle of 120 degrees to each other. We're asked to find what? The resultant force and the equilibrium. We have two of such forces. First of all, we have these two forces. We said that they are inclined to each other, meaning their position at an angle of what? 120 degrees to each other. And this one is what? 10 Newton, and this is what? 10 Newton. I will say that the resultant force is a what? The resultant force is a single force that has the same effect as the two forces. So if you want to find the resultant force here, you find out that if I draw a line this way, can you observe this now? This is prime, so if this is 20 Newton, this must be what? 20 Newton. Okay? Then we can divide this into two equal parts. So if we divide this will be what? 60 degrees. So by calculation, we are looking for what? By calculation, since this side is 60, remember this side is 60, right? And this is 20 and this is 20, it means that this side is what? 60 Newton as well. And therefore the last side should be what? 60 Newton. 60 degrees. Right. So if the angles are 60 degrees each, we can say that from our sine rule, we can say which side is opposite to which angle is opposite to you can say 20 over what? Sine 60 is equal to what? Let's call the resultant force R. Is equal to what? R over what? Sine. Okay? So if this is 60, you can say it's equal to R, because this is 20 Newton here, and this is 20 Newton. Okay? So we can say it's equal to R over what? Sine 60. Do you understand the simple idea here? Since the angle has been divided in two, one part of it is what? 60 degrees. The other part is 60 degrees. Do you understand? And this part is 20 Newton, this is 20 Newton. Okay? So since this is 60, we can say that 20 over sine 60 is equal to what? R over sine of this angle here. Okay? Or we can also use the cosine rule. We can say, speaking about this side is what? The resultant. We can say that R, okay, is equal to what? R squared is equal to 20 squared plus 20 squared minus 2 times 20 times 20 cos of this angle will have the same value. So which one is better? The sine rule. So by sine rule, since this is 60, and remember this is what? An isosceles triangle. So this is 20 Newton and this is 20 Newton. And this angle here is what? 60. Then this must be what? 60. So we can say that 20 over what? Sine 60 is equal to what? R over sine 60. So at the end of the day, sine 60 will cancel sine 60. So R is, the resultant force is what? 20 Newton still. So the resultant force is 20 Newton at what angle? At an angle of 60 degrees. Because here is what? 60 and here is 60. So the resultant force that will be 20 Newton at an angle of 60 degrees. The same thing, the equilibrium force is the force that is what? Equal and opposite in direction as the resultant force. So the equilibrium force should be what? 20 what? Newton in opposite direction. The next example, we have example 2. Before we go to example 2, let us look at the principle of triangle of forces. It is a simple principle, and it states that when we have three forces that are in what? Equilibrium can be represented by the three sides of a triangle. So if I position three forces in a place of equilibrium, we can represent such forces with the size of a triangle. And how do we effectively do that? Let's look at an example. Example 2. A mass of 2 kilograms is supported by two chords. So as we are reading this example, I want us to visualize how the structure will be like. So let's write this part of the board and see how this structure will be like. So we're saying that a mass of what? 2 kilograms is supported by what? 2 chords. That makes an angle of 30 degrees and 50 degrees to the vertical. So we have, let's say, we have the roof, and we say that this mass here, this is supported by, there's a mass here, and the mass is supported by 2 chords. So that mass is what? 2 kilograms, okay? The mass is 2 kilograms. So what's the force that will be acting downward? That is 2 times 10. Because when we speak of the force acting downward, that's the weight. Do you understand? We work with weight in physics, which is 2 times 10, and that is 20 Newton. And we say that one of the forces, they are inclined at an angle of 30 and 50 degrees to the vertical respectively. It means that this angle here to the vertical, that's to the straight line, not to the horizontal, is inclined at what? 30 degrees, and this is inclined at what? 50 degrees. One has to find the tension. The tension is the force on the string. The tension on these 2 strings. Now, with this, I can take a parallel line. Do you understand? If I do this, it means that this line is parallel with this, right? Do you understand? This line is parallel to this. Are you following? Okay? Then if I bring another line this way, another dotted line, it will mean that this is parallel to this angle here. So I want us to get out the angle. Then this will become the what? The resultant. Okay, because the resultant is also 20 Newton. So we said it is, because this is the equilibrium force, so the resultant should be 20 Newton. So if I draw it this way, you find out that to the vertical, if you observe the angles here, correspond alternate angle. This angle is alternate to this. So this angle will be what? 30 degrees. Why this angle is what? Alternate to which angle? If you observe from the diagram, you find out that this is 30 here. Where is this angle alternate to? 30 degrees here. 50 degrees. So this is 30, this must be 50. Okay? So therefore means that this is also what? 50 degrees. If you observe. Can you observe that corresponding angles, these 2 angles, the angles are corresponding. Okay? So we can say that both of them are 50 degrees. By this angle and this angle are also 30 degrees. So by calculation, we can draw out a triangle from this. In our calculation, the triangle will be in this nature. So let's call this X and call this what? Y. So the resultant force is what? 20 Newton. This is what? 30 degrees, and this is 50 degrees. So by calculation, what we have is, we make use of the cosine rule. We can either make use of the sine rule or the cosine rule. So from calculation, if this is 30 degrees and this angle here is 50 degrees, what's the last angle here? That is 100 minus what? 8. 180 minus 80, which is 100 degrees. So this angle is 100 degrees. So we can say that 20 over what? Sine 100 is equal to what? X over sine 30, which is also equal to what? Y over sine 50. What is 20 over sine 100? Can I have a calculator, please? This will give us 20.31. So times sine 30 is equal to what? X. So X is equal to what? Times sine 30. So X is equal to 10.15 Newton. That's the first on one of the chords. Then the first on the other chord is what? 20.31 times what? sine 50. So y is equal to what? 20.31 times sine 50, which is equal to 15.56 Newton. So these are the forces that you find on the two curves by calculation. The next thing we're going to look further from here is moment of the force. But before we do that, I'd like us to take some more examples to better explain this equilibrium of forces involving triangular forces.